If you ever wondered why that 1985 Honda in your neighbor's garage still fires up every morning while your 2020 bike needs constant attention, here's what's really happening. You're part of a much bigger story that the motorcycle industry doesn't want you to understand. Right now, while American and European bike owners are dumping thousands into repairs and rebuilds, Japanese bike owners are quietly riding the same machines for decades without major issues. Master mechanics who've worked on everything from vintage Hondas to modern Ducatis are calling these techniques the forbidden knowledge. This happened because Japanese engineers built maintenance philosophies around 500,000-mile expectations, not planned obsolescence. We're talking about simple procedures that cost under $50 but can extend your bike's life by 200,000 miles. The numbers are staggering. Bikes using these methods routinely hit 300,000, 400,000, even 500,000 miles on original engines. So if you're tired of expensive repairs and want your bike to run like those legendary Japanese machines, here are the 5 secrets they don't want you to know. Hit subscribe and that notification bell now, but before we start, ever wonder if your mechanic is laughing all the way to the bank with your repair money? Number 5. The Kush Drive Rubber Rotation. Coming in at number 5, we have the Kush Drive Rubber Rotation. Most riders have never even heard of this component, but ignoring it will destroy your transmission. Deep inside your motorcycle's rear wheel hub lies a component that almost no riders know about, yet mechanics see destroying transmissions every day. It's called the Kush Drive, a series of rubber dampers hidden inside the rear sprocket carrier assembly. These humble rubber blocks are the only thing preventing catastrophic shock loads from destroying your transmission. And here's the shocking truth. Replacing these 40 rubber components can save you from a 40 rubber components, can save you from a 40 rubber components, can save you from a 2000 transmission rebuild. What exactly does the Kush Drive do? Every time you accelerate, brake, or hit a bump, massive forces travel through your chain or belt. Without something to absorb these impacts, they would transfer directly to your transmission's output shaft and gears. Japanese engineers discovered this problem decades ago and developed the Kush Drive system as an elegant solution. Rubber dampers that compress slightly under load, absorbing shocks before they reach delicate transmission components. Here's where riders go wrong. These rubber blocks wear down gradually over time, creating what mechanics call slop in the rear hub. You'll notice this as a slight clunk when getting on and off the throttle. Most riders ignore this minor symptom, unaware of the destruction happening inside their transmission. As the Kush Drive deteriorates, steel-on-steel contact begins occurring with every throttle change and bump in the road. I see transmissions destroyed by worn Kush Drives almost weekly, says independent motorcycle technician Mike Rodriguez. The customer comes in for an unrelated service. I notice excessive play in the rear sprocket, but they decline the repair because they don't understand the consequences. 6 months later, they're back needing a complete transmission rebuild that costs 50 times more than the Kush Drive replacement would have. The spline destruction process is insidious. Each impact from a worn Kush Drive hammers microscopic amounts of metal from the output shaft splines. Over thousands of miles, these splines gradually become rounded until they can no longer effectively transfer power. By the time you notice symptoms like transmission popping out of gear or difficulty finding neutral, the damage is irreversible. The only solution becomes a complete transmission rebuild requiring case splitting, one of the most expensive repairs in motorcycling. The prevention protocol is remarkably simple and affordable. Every 15,000 to 20,000 miles, have your Kush Drive inspected by removing the rear wheel and checking for excessive play in the sprocket carrier. If more than 2 to 3 millimeters of movement exists, replace the rubber dampers immediately. The parts cost between $30 to $60 depending on your motorcycle model, and labor typically runs 1 to 2 hours. Japanese manufacturers like Honda and Kawasaki build their maintenance schedules around this type of preventative maintenance, but most dealer service departments skip these inspections because they're labor-intensive compared to the profit generated. They'd rather wait until your transmission fails completely so they can sell you a much more expensive repair. Consider this real-world example. A 1992 Honda CB750 came into a shop with 412,000 original miles on the engine and transmission. When technicians disassembled the bike for restoration, they discovered the owner had replaced the Kush Drive rubbers every 20,000 miles without fail. The transmission splines showed minimal wear despite the extraordinary mileage, proof that this simple maintenance hack truly works. So if you want your motorcycle to achieve legendary Japanese reliability, Start by checking your Kush drive condition immediately and implementing a regular inspection schedule. This $40 part replacement could literally save your transmission from becoming scrap metal. Number 4. The brake fluid hygroscopic flush. At number 4, we're exposing the brake fluid scam that's destroying $1,800 ABS modules while dealers count their money. Here's a fact that should terrify every modern motorcycle owner. That clear liquid in your brake lines is actively destroying your braking system from the inside out, and your dealer isn't telling you about it. DOT4 brake fluid, the standard in most motorcycles, is what engineers call hygroscopic, meaning it actively absorbs water from the air. This property is intentional, designed to prevent water droplets from forming in your brake lines. The problem: that absorbed water becomes a corrosion factory inside your expensive ABS module. Japanese braking systems from manufacturers like Nissan and Tokiko are engineering marvels, packed with precisely machined valves and passages that modulate pressure hundreds of times per second. These same precision components are extremely sensitive to corrosion from moisture-contaminated brake fluid. Once corrosion begins inside an ABS module, it's only a matter of time before valves begin sticking and sensors fail. The ABS module is essentially the computer and hydraulic control center for your entire braking system, explains brake specialist Sarah Thompson. Modern units contain aluminum components, solenoids, and tiny valve bodies with clearances measured in microns. When contaminated fluid introduces corrosion, these precision components begin to stick, leading to ABS malfunctions that are frequently irreparable. Here's where the industry's profit model becomes clear. Dealers know that annual brake fluid flushes prevent this expensive failure, but they don't aggressively recommend them for a simple reason. Replacing failed ABS modules generates massive profit. The average dealer charges between $1,500 to $2,200 to replace a seized ABS unit, compared to just $1,500 to $2,200 to replace a seized ABS unit, compared to just $100 to $150 for a brake fluid flush. Many service advisors are actually incentivized to avoid preventative maintenance because catastrophic failures pay their commissions. The numbers are shocking. A complete brake fluid flush costs approximately $30 in materials and takes about 30 minutes of labor. An ABS module replacement requires special diagnostic equipment, 3 to 4 hours of labor, and an expensive OEM part. The math is simple. Dealers make about 10 times more money replacing failed components than preventing the failure in the first place. Japanese engineers design these systems with the expectation of regular fluid exchanges. The factory service manuals for Honda, Yamaha, Suzuki, and Kawasaki all specify complete brake fluid replacement every 1 to 2 years regardless of mileage. Yet walk into any dealership service department, and you'll find this critical service isn't pushed with the same urgency as oil changes or tire replacements. The aggressive cycling solution is straightforward. Flush your brake fluid completely every 12 months, regardless of mileage or appearance. The process involves draining all old fluid from the system and replacing it with fresh DOT4 fluid that contains minimal moisture content. For riders in humid climates, consider even more frequent intervals, as often as every 8 to 9 months. For the mechanically inclined, this is a DIY-friendly procedure requiring a few simple tools. The key is complete fluid replacement, not just topping off the reservoir. You'll need to open bleeder valves at each caliper and pump fresh fluid through until all old fluid is purged from the system. Consider this stark reality. A 2018 Kawasaki with ABS came into a shop with complete brake failure at just 22,000 miles. The ABS module had internally corroded, requiring a $1,800 replacement. Just 2 weeks later, an identical model with 86,000 miles arrived for routine service with perfectly functioning brakes. The difference: the high mileage owner performed annual brake fluid flushes without fail, while the lower mileage bike had never had its fluid changed. This simple maintenance hack doesn't just save money, it potentially saves lives by ensuring your braking system functions as designed in emergency situations. Japanese engineers build these incredible braking systems to last hundreds of thousands of miles, but only if you follow their fluid maintenance protocols rather than dealer profit schedules. Number 3. The JSOM A2 oil hack. Number 3 reveals the oil industry conspiracy that's been draining your wallet, while mechanics laugh all the way to the bank. Walk into any motorcycle dealership service department, and you'll be sold premium branded motorcycle oil at $15 to $20 per quart. The bottles feature racing graphics, impressive technical claims, and manufacturer endorsements. But here's what the industry doesn't want you to know. Many technicians working in those same dealerships use bulk generic oil in their personal bikes while selling you expensive branded products. The reason? They understand what matters is the certification on the back label, not the marketing on the front. The key to Japanese motorcycle oil longevity lies in a standard called JASO MA2. The Japanese Automotive Standards Organization created this specification specifically for motorcycles with shared sumps, engines, where the same oil lubricates the engine, transmission, and wet clutch. This engineering approach creates unique demands that regular automotive oils simply can't meet. Japanese engineers design these engines with incredibly tight tolerances and expect specific oil properties, explains lubrication specialist Robert Chen. The JASO MA2 certification guarantees the oil meets these requirements, regardless of brand name or price. Many premium-priced motorcycle-specific oils are essentially the same base stocks and additive packages as more affordable options. The friction modifier trap is where most riders unknowingly damage their motorcycles. Standard automotive oils contain friction modifiers designed to improve fuel economy in cars. These same additives are catastrophic for motorcycle wet clutches, causing slipping, glazing, and eventually complete clutch failure. A replacement clutch pack typically costs $300 to $500 in parts, plus several hours of labor, all because of using the wrong oil despite having the right viscosity. The JASO standard truth is simple. Any oil meeting JASO MA2 certification is safe for your Japanese motorcycle, regardless of brand name or price point. The certification process involves standardized testing for clutch compatibility, gear protection, and engine protection. This small symbol on the back of the oil container is literally the only thing that matters when selecting motorcycle oil. Here's where the real savings appear. Certain heavy-duty diesel oils, like Shell Rotella T6, synthetic carry JASO MA new certification, while costing half what motorcycle-specific brands charge. These oils are engineered for extreme pressure protection in diesel engines, making them ideal for motorcycles while costing 10 to 12 per quart instead of 10 to 12 per quart instead of 18 to 25. I've been using Rotella T6 in Japanese motorcycles for over 500,000 combined miles across dozens of bikes, says veteran motorcycle technician James Wilson. Cut open an engine using this oil at 100,000 miles, and it looks like new inside. Meanwhile, I regularly see engines running expensive branded oils with significant wear at half that mileage. Consider this real-world example. A 2001 Yamaha FZ1 arrived at a performance shop for valve adjustment with 278,000 original miles. The owner had exclusively used Shell Rotella T6 diesel oil since new, changing it every 3,000 miles without fail. When technicians measured the cylinder bores, they found wear of less than 0.001 inch, virtually unheard of at that mileage. The transmission and clutch showed similarly minimal wear, despite the extraordinary mileage. This simple oil hack doesn't just save money on lubricants. It potentially saves your entire engine from premature wear, while extending clutch and transmission life dramatically. All by ignoring expensive marketing and focusing on the certification that Japanese engineers actually care about. Number 2. The voltmeter coolant test. At number 2, we're uncovering the electrical death that's eating your cooling system from the inside out. Here's a silent killer that's destroying thousands of Japanese motorcycles right now: electrolysis in your cooling system. This invisible electrical current is literally dissolving aluminum components from within, while most owners remain completely unaware until catastrophic failure occurs. What's worse, this destruction can be detected and prevented with a $15 multimeter and 5 minutes of your time. Japanese manufacturers like Honda, Kawasaki, Yamaha, and Suzuki build their liquid-cooled motorcycles with extensive aluminum components to save weight. This includes radiators, water pumps, and even portions of the cylinder head and block. While aluminum provides excellent heat transfer and weight savings, it has one critical vulnerability. It's highly susceptible to galvanic corrosion when exposed to electrical current. Coolant is actually a mild electrolyte, explains cooling system specialist Dr. Tanaka. As it ages, it becomes more conductive, allowing stray electrical currents to flow through the cooling system. These currents cause metal ions to migrate from one component to another, literally eating away aluminum parts molecule by molecule. The battery effect is where the real damage occurs. Your cooling system essentially becomes an unintended battery cell, with different metals creating a voltage potential. This electrical activity accelerates dramatically as coolant ages and becomes contaminated with metal particles. Most riders have no idea this is happening until a radiator springs a leak or a water pump seizes, by which point the damage is severe and expensive. Here's where Japanese engineers discovered a crucial testing method that almost no dealers or service manuals mention: the 0.3 volt death line. By using a simple digital multimeter, you can measure the electrical voltage in your coolant. If that reading exceeds 0.3 volts, accelerated corrosion is actively destroying your cooling system. The test procedure is remarkably simple. Set your multimeter to DC voltage, place the negative probe on a solid engine ground, and immerse the positive probe in the coolant, being careful not to touch metal components. A reading above 0.3 volts indicates problematic electrolysis that requires immediate attention. Readings above 0.7 volts indicate severe electrolysis that is rapidly destroying components. Why don't dealers promote this test? The answer is profit-driven. A complete cooling system flush costs approximately $80 to $120, while replacing damaged components generates thousands in revenue. A typical radiator replacement runs $80 to $120, while replacing damaged components generates thousands in revenue. A typical radiator replacement runs $80 to $120, while replacing damaged components generates thousands in revenue. Atypical radiator replacement runs $400 to $800, water pumps cost $300 to $500 plus labor, and head gasket failures from corroded cooling passages can exceed $300 to $500 plus labor. And head gasket failures from corroded cooling passages can exceed $300 to $500 plus labor. And head gasket failures from corroded cooling passages can exceed $1,500 in repair costs. I test coolant voltage on every bike that comes through my shop, says independent mechanic Jason Wong. About 40% of bikes over 3 years old show dangerous voltage levels, yet none of these owners had any idea their cooling systems were being destroyed from within. A simple flush and inhibitor addition solves the problem immediately. The voltage monitoring protocol is straightforward. Test your coolant voltage every 6 months, and immediately flush the system if readings exceed 0.3 volts. Use only manufacturer-recommended coolant with proper corrosion inhibitors, and replace it every 2 years regardless of appearance or mileage. For added protection, consider adding a dedicated cooling system grounding wire, a technique used by experienced Japanese motorcycle technicians to provide a safe path for stray currents. This simple diagnostic technique costs nothing but prevents thousands in repair bills while extending your motorcycle's life dramatically. Japanese engineers build these cooling systems to last the lifetime of the motorcycle, but only if you prevent the invisible electrical destruction they're susceptible to. Number 1. The shim under bucket valve audit. And finally, at number 1, the most expensive mistake Japanese bike owners make: waiting for valve noise that never comes. The biggest misconception in motorcycle maintenance is believing you'll hear valve problems before serious damage occurs. With American and European motorcycles using pushrod or rocker arm valve trains, this might be true. Failing valves typically create distinct tapping sounds as clearances increase. But Japanese motorcycles predominantly use overhead cam designs with shim under bucket valve adjustment, and these systems get quieter as they fail, not louder. This is the most expensive misunderstanding in motorcycling, explains engine builder Michael Tanaka. Owners of Japanese bikes are waiting for warning sounds that will never come until catastrophic failure occurs. By the time they notice any symptoms, the damage is already severe and expensive. The silent killer myth persists because it contradicts common mechanical intuition. As valves and seats wear in Japanese overhead cam engines, the clearance typically decreases rather than increases. The valve recedes further into the head as the seat erodes, creating a tighter and tighter clearance. This makes the engine run more quietly, even as damage accelerates. The heat transfer failure is where the real destruction happens. Valves dissipate approximately 75% of their heat through contact with the valve seat during the closed portion of the cycle. As clearances tighten, the valve spends less time fully seated, dramatically reducing heat transfer. The valve begins retaining more heat with each combustion cycle, eventually reaching temperatures that cause the valve to burn, warp, and potentially snap. Factory service intervals for valve inspections are typically 15,000 to 24,000 miles, notes experienced technician Robert Suzuki. But the honest truth is that valves often begin receding significantly by 10,000 to 12,000 miles, especially in high-performance models. By performing inspections at half the factory interval, we catch recession before it becomes dangerous. The physical measurement protocol is straightforward, but labor-intensive, which is precisely why many service departments don't push for regular inspections. The process requires removing valve covers, rotating the engine to precise positions, and physically measuring clearances with feeler gauges. There are no shortcuts or quick methods to check these clearances, requiring methodical disassembly and precise measurement. For Japanese motorcycles, the ideal approach is to perform valve clearance inspections every 7,500 to 10,000 miles, approximately half the factory recommended interval. While this seems excessive to many owners, consider this real-world example. A 1998 Honda VFR 800 came into a performance shop with 386,000 original miles on the engine. When technicians disassembled the top end for inspection, they discovered the owner had performed valve adjustments religiously every 8,000 miles without fail. The valve faces and seats showed minimal wear, despite the extraordinary mileage, proof that this maintenance approach truly works. I've rebuilt hundreds of Japanese motorcycle engines, says veteran technician David Yamamoto. When we open up engines that have had regular valve adjustments, they're immaculate inside even at extreme mileages. Open up one that's followed factory intervals or extended them, and you'll find burned valves, damaged seats, and expensive repairs waiting to happen. This simple maintenance principle doesn't just save your engine from destruction. It potentially saves thousands in repair costs, while ensuring your motorcycle remains reliable for hundreds of thousands of miles. Japanese engineers design these valve trains to last virtually forever, but only when maintained according to their engineering principles, rather than marketing-driven service intervals. Conclusion. So there you have it. 5 Japanese maintenance secrets that can transform any motorcycle from a 50,000-mile money pit into a 500,000-mile legend. The pattern is clear. Prevention, not repair, creates mechanical immortality. The motorcycle industry profits from your ignorance, selling you replacements instead of knowledge. These simple techniques cost pennies compared to the catastrophic failures they prevent. Your Japanese bike was engineered for extraordinary longevity. Now you know how to achieve it. Has your dealer ever mentioned these methods? Which secret shocked you most? Comment below and subscribe. Our next revelation about what motorcycle manufacturers are hiding will change everything you thought you knew about two-wheel longevity.